Venus, often referred to as Earth's sister planet due to its similar size and proximity, presents a paradox. While its surface conditions are extraordinarily hostile, there are intriguing hints that microbial life could potentially exist in its upper atmosphere. Surface conditions. The surface of Venus is one of the most inhospitable environments in our solar system. Extreme temperatures. The average surface temperature on Venus is around 467 degrees Celsius, 872 degrees Fahrenheit, hot enough to melt lead. High pressure. The surface pressure on Venus is about 92 times that of Earth's, equivalent to the pressure found 900 meters, 3,000 feet, underwater on Earth. Acidic atmosphere. Venus has a thick atmosphere composed mainly of carbon dioxide, 96.5%, with clouds of sulfuric acid, making the environment highly acidic and corrosive. Atmospheric layers. Despite these harsh surface conditions, the upper atmosphere of Venus, specifically between 48 to 60 kilometers, 30 to 37 miles, above the surface, presents a more temperate environment. Temperature. This layer of the atmosphere has temperatures ranging from 30 to 70 degrees Celsius, 86 to 158 degrees Fahrenheit, which are within the range suitable for some extremophiles, microorganisms that thrive in extreme conditions. Space missions. Several space missions have explored Venus, providing valuable data about its atmosphere and surface. Mariner 2, 1962, the first successful flyby of Venus, which measured its surface temperature and confirmed it was much hotter than previously thought. Venera program, 1961 to 1984, Soviet missions that successfully landed on Venus and transmitted data from its surface, revealing its extreme conditions. Magellan, 1989 to 1994, NASA's mission that mapped the surface of Venus using radar, providing detailed images of its topography. Phosphine detection. In September 2020, a groundbreaking discovery was announced by a team of astronomers led by Jane Greaves of Cardiff University. They reported the detection of phosphine, pH3, in the clouds of Venus using the James Clerk Maxwell Telescope, JCMT, in Hawaii and the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile. Phosphine is a gas that, on Earth, is produced either by industrial processes or by anaerobic organisms, microorganisms that live without oxygen. The detection of phosphine in Venus's atmosphere raised the tantalizing possibility of microbial life, as phosphine is difficult to produce through abiotic, non-living, processes under Venusian conditions. Microbial life hypothesis. If microbial life exists in Venus's atmosphere, it would likely be in the form of extremophiles adapted to the acidic, high-temperature, and high-pressure conditions of the cloud layer. These hypothetical microorganisms could potentially utilize sulfuric acid. Some Earth microbes can thrive in acidic environments, suggesting the possibility of sulfuric acid-resistant life forms on Venus. The idea of life on Venus remains one of the most intriguing and controversial topics in planetary science. While the surface conditions of Venus are incredibly hostile, the more temperate and chemically complex upper atmosphere offers a potential habitat for extremophiles. The detection of phosphine has reignited interest in Venus as a target for astrobiological exploration, prompting calls for new missions to probe its atmosphere and search for signs of life.